Hi. I am going to be discussing work being carried out by Touch Graphics on a new method for sensing touches. And this is, I think I'm calling the encephalopod, and it is a plastic sphere that's 6 inches in diameter, and it has 10 potato chip looking plastic finger pads that have been glued to the surface, and each one of those finger pads has a wire running up from below through the empty sphere and out to this long spinal cord looking tail. At the end of that tail is a device which has 10 plugs in it, one for each of the finger pads wires, and on this side it has a USB connector here, to which I'm about to connect a cable. Oops, and there goes my plastic sphere onto the floor. Now, I put this in here, and the computer behind me has now made connection with the device, which is then connected by all these wires to this thing. And as I touch this ball with my fingers, you're going to see these spheres, or these circles on this computer display. You're going to see them getting bigger and smaller depending on how hard I touch. You're also going to hear some tones which are being generated also in response to the intensity of my touch. In other words, the amount of pressure that I'm exerting on this surface. And it's quite delicate. I mean, I can go very, very lightly, or I can press a little bit harder, and it just keeps getting bigger. And so the range of pressure sensitivity is pretty remarkable, because it can tell this very small amount. I'm just barely tapping it. And it even knows these very, very strong pushes. So I could do it on all 10 channels at the same time, 10 fingers, like this. So now you can see all 10 fingers are going all at the same time. So what we end up with is a 10-channel multi-touch pressure-sensitive switch that can then be used to control any device or any system that requires that level of simultaneous control of multiple things. And this has a number of applications. In control systems, it would be possible to produce very inexpensive, very tactile and textured and very, very particularly shaped handlebar grips and other kinds of hand tools that embody these sorts of zones where your fingers are directed to rest and where you are then able to exert pressure in very specific ways in order to, and combinations in order to control a lot of things. So you may be wondering how it works, and that's actually the heart of the discussion. The reason why this works was sort of discovered by accident, but it is a factor of the fact that the capacitive touch sensing approach looks at the percentage of skin as in ratio to the size of the electrode that's being touched. So if we think of this potato chip here as being a thing of maybe 1 square inch of surface area, and then my finger touches it, my finger, the proportion of skin that's touching affects the electrical signal that's being detected and interpreted by the touch sensor device. So there's a very, very precise mathematical relationship between the percentage of skin in relation to the electrode and the capacitive value that is sent to the computer. So we have the ability, that means, to produce these sorts of touch-sensitive surfaces for a very, very low cost, because this is really a piece of plastic. There are no electronics in this at all. And the only electronics involved are this device here, which is an extremely simple USB peripheral, which could be manufactured for $5 or $6. So then we realize, possible applications such as a motorcycle where you had a grip that placed your fingers in specific position, and then permitted you to control the throttle, the brake, the radio volume, all by just squeezing your fingers in particular ways. The savings in switches and other kinds of electromechanical products and parts would go way down. So there does seem to be a very, very clear economic function of a device like this, if only to replace other kinds of control mechanisms. Now, this only works with bare skin at this point, although theoretically it could also work through gloves. Certainly, I would imagine surgical gloves would be no problem. Other thicker gloves might begin to introduce a lot of inaccuracy in the sensing, but certainly gloves are possible. The applications that I see for this are in the area of musical expression, of control of home theaters and other environments. I think there are underwater applications for this. For example, a housing that enclosed a camera to keep it dry could use this kind of sensing, because there are no openings in the enclosure to make this work. And so we see a lot of possibilities for this, and therefore we'll be pursuing a patent, a utility patent, right away. And this video is intended to be used as part of the process of explaining this product to the people who are going to be preparing the patent filing. So thank you very much, and please get in touch with me, Stephen Landau at sl@touchgraphics.com. Our website is www.touchgraphics.com.